Good evening, class. My name is Tyler Draper. This is Math for Teachers 1. This will be my 6 homework questions that I'm going to go over with you today. Please just follow along. Homework number 1, let U equal A, B, C, D, E, F, G, H. So we're going to have, after that, A equals B, C, D, G, H, B equals D, F, H, and C equals D, G, H. Create a 3-ring Venn diagram organizing U, A, and C into groups. Forgot to also include B on there as well. Okay, so let's take a look. We see that we're going to have 3 groups inside of U. So A, B, C will be inside of U. U is the big box around. Our first letter is A. A is only shared by U, so it'll be outside the Venn diagram. B is shared by U and A, but not any of the others, so it'll be an A and B. So these go together, remember that. A is inside of U. C, that's shared by A and U, so it's there too. D, let's see, D is shared by A, B, C, and U, so that'll be in the very middle here. We see this area right in here of the actual 3 rings, or here is where they all share. These are where 2 share, and this is where none of them share unless they're a part of U as well. Okay, so that was D. E is not shared by any of them except U, so we have them on the outside here. F is shared by B only, or B and U, so we have F by the B there. Okay, let's look here. G is shared by A, C, and U, so we put it in between A and C there. H is shared by all of them, so we put it right beside D down there. Now, we organize this graph to be able to get to our next slide, which we will use. Okay, so in this one, as you can tell, I've brought the Venn diagram over to this slide. We are going to do unions and intersections. So an intersection is where 2 points crisscross and they share a point or a letter. And union is a set where they share all that are in that group. Okay, so we'll take a look here at A. B union C. So we have B, we have C, that is a union. They share F, H, D, and G. A intersects B, A intersects B, and they share the same 2 points, H and D. B intersects C, they share H, D, and G. Hope you're kind of following along and picking up on them as we go along here. If you need to slow down and look at it, you can always pause, I don't mind. A union C. So we'll see A, circle A, circle C, all those points above. So B, C, D, G, H will be the points. Now, letter E here, it says A, which stands alone, and that will be F. Okay, so yeah. And then the next one we have A intersects C. So we see that A and C where it intersects. We have D, G, and H. We have these 3 areas right here where it looks almost like a football where they crisscross each other. And G here, it says A union the intersection of B and C. So B and C intersect here in this area. And then the union of those would be B, C, D, G, H. So the only point that's really left out here, it's just the F and B and the A and E, of course. But so we have this full circle, these intersection, because this intersection of B and C, and then all that A has in its union. See that there? All right, thank y'all. We'll go to homework question number 2. Construct a Venn diagram in 12 shapes, and the Venn diagram shown to the right. It actually means the bottom right down here. Okay. With attributes described by shape, size, and color, let C, H, and T denote the sets of circular, hexagonal, and triangular shapes respectively. Let S, L, R, and B denote the sets of small, large, red, and blue shapes respectively. The set A, the circle here in the middle, contains the shapes that are small and not a triangle. So A equals S intersection of T. So they are small and not a triangle. So what I've done is I've created this little graph right here. I hope you can take a look at with C, H, and T. They said they would be circular, hexagonal, and triangular. S, L, R would be small, large, and red. It's good to get those nice and organized. That way we can resort back to them in our next problem. Okay, homework number 2A. Demonstrate which shapes are found in the set L intersects H. Okay, so we have L. We know that's large. We have H, which is hexagons, and we have an intersection. That means it can only be those two. So it'll be large hexagons. Demonstrate which shapes are found in the set C union H. C is circular. Union, that means we can share the two. And H is hexagonal. So they could be hexagonal shapes or circular shapes. So we have hexagons here, hexagonal shapes, and and circular shapes. Demonstrate which shapes are found in the set T intersects R. T is triangular, R is red. That means we're going to have intersection, means we can only have those ones really. It'd be triangular red shapes. So we have a triangular red shape here. We have one here. This one's small, this one's large, but they are still classified as T intersects R. Demonstrate which shapes are found in the set C intersects S intersects R. Okay, so C is circular, S is small, R is red. So that means we're going to have a circular small red shape. Alrighty. And we also, I put this little helper in here that describes intersection and union, so we can see the symbols and use those better off. Homework number 3. Write the Indo-Arabic Arabic equivalent of each of the following. So right here we have 3 of the wood sticks looking deals, 5 of the open horseshoes, and 4 of the lines. So that's going to be 30,000 for those 3, 50 for these 5, and 4 for those. We get 30,054. Now we're going to look here at B. MCM XXX VLL equals. Okay, so we got our symbols here. It tells us the amount. Now this is very important that we take a look at these rules. The symbol M represents the value 1,000. Next, consider the symbol CM. These represent the value 900. XXX equals 30, and the symbol and lines, the 3 lines represent 3. So we have M equals 1,000, CM equals 900. Notice that is a very important rule. You could add 1,900 right there and mess up. CM equals 900, not 1,900. So we have 1,900 with the CM. The 3 X's, that it equals 30. 1,930. 5 for the V, 2 for the ones. So we have 1,937. 5 plus 2 is 7. We have our answer. Voila. C is pretty self-explanatory. Each symbol represents 10. This one on the right, this one equals 1. You get 41. Now D, this one's very tricky, and I'll go over this one extensively with you. Okay, the given Mayan numeral has 4 place values. From top to bottom, the place values are 70, 200, 360, 20, and 1. Represent the numeral in each row as familiar Indo-Arabic numeral using the table below. So, most importantly, this symbol here on the very top, it represents 7,200 place value. This one 360, this one 20. So what does this one equal? That's right. As given, it equals 1. Now we need to look at this chart down here to figure this out, what each one equals. So this one here, just a pure line, is going to be 5. So we have 5 times our place value, 7,200. Make sure that's in parentheses. Plus, this next symbol here is 6. 360 was our given value on that one. Parentheses plus, that's going to equal 3 times our place value of 20. Plus, we have 17 here times our last value that you said was 1. Altogether, we get 38,237. I put it on the PowerPoint, but it did slide that 7 down, but you can still see it right here. Basically, what we're doing is we're finding the value of the symbol, multiplying that by its place value, and then adding all 4 of those together to get our grand total. All right, that's homework number 3. All right, homework number 4, we're going to multiply by lattice algorithms. We have 4 problems we're going to do here. Okay, lattice algorithm. So lattice is where we draw out our square here. Drew out our square, we divide it into certain areas, 2 by 2 in this case, and then we write our diagonal lines to divide our areas up. 28 times 32, we got 28. We have 32. Each box represents multiplication factors. 8 times 3 is 24. 8 times 2 is 16. 2 times 3 is 6. 2 times 2 is 4. Then we're going to add these numbers up real quick here. We bring our 6 down. 4 plus 1 plus 4 equals 9. 2 plus 6 is 8. We don't have anything in that one, so that's a 0. So what does 28 times 32 equal? That's right. It equals 896. As you can see, I've placed an arrow down here to show you that our answers are always going to be on the left and bottom side of the lattice square. Oh, and they get bigger too. So here we go. Multiply 273 by 628 using the lattice algorithm. Okay, so first thing I'll ask you here, what is 3 times 6? That's right, it's 18. 3 times 2 is 6. Don't forget your zeros there. I've left out a 0 on my last one. 3 times 8, 24. 7 times 6, 42. 7 times 2 is 14. 7 times 8, 56. 2 times 6 is 12. 2 times 2 is 4. 2 times 8 is 16. Let's add up some of these diagonals here and get this answer. 4 plus 0, oh well, will be 4. 6 plus 2 is 8 plus 6 equals 14. Okay. So we have a 4 here. What does this 1, highlighted yellow 1 right there, mean? That's right. That is where we have brought the extra place value up. So 1 plus 8 plus 4 plus 5 plus 6 equals 24. Bring our 2 up. 2 plus 1 plus 2 plus 1 plus 4 plus 1 equals 11. Bring our 1 up again. 1 plus 4 plus 2 plus 0 equals 7, and then our 1. So our answer is going to be 171,444. Good job. Let's go to the next one, C. Multiply 964 by 593 using the lattice algorithm. So I hope we're picking up a trend here. When we multiply three digit numbers by another 3-digit number, we're always going to have 6 digits in that number. Whereas so in this one, we're going to do 4 digits by 3 digits, and we have 7. Hope we can see that trend there. Here we did 2 by 2, and we had 3 digits. All right. We were on C here. So 5 times 4 is 20. What is 4 times 9? Okay, I'm going to show you the 9 trick real quick. With our 9s, remember we have 10 fingers. 9 times 4. I'm going to put down this thumb here. Or sorry, this pointer. This is 1, 2, 3, 4. We get 30. That's 3. Those are 3 fingers. We got 6 here. 36. That's a good trick to use for 9s. 4 times 3 is 12. 6 times 5, 30. 6 times 9, that's 6. 54. 6 times 3, 18. 5 times 9 is 45. 9 times 9, ooh, that's a big one. So we have 5, 6, 7, 8, 9. So we have 8, 1. So this is 1. These other ones are going to be 8. So we have 81. 9 times 3 is 27. We'll add these up. We get 2. We get 15. Bring your 1. Then we get 16. We get 11, 17, and 5. Okay, what is our answer? Can you say the answer? All right, our answer is going to be 571,652. Remember, our answer is always on the left and the bottom. Homework problem number 4D. Oh, this one's going to be large. We have 4,952 by 243. Okay, we'll start up at the top right. We get 2 times 2 is 4, 2 times 4 is 8, 2 times 3 is 6, 5 times 2 is 10, 5 times 4 is 20, 5 times 3 is 15, 9 times 2 is 18, 9 times 4 is 36, 9 times 3 is 27, 4 times 2 is 8, 4 times 4 is 16, 4 times 3 is 12, and then we're going to get our numbers here. We have 6, 13, 13, 13, 20. Wow, that's yet large. That's a big group here. 20. And then we have 12. Bring our 1 down. And let's see. Can you say this number? Do you know what the answer is? That's right. Our answer is going to be B. And it's going to be 1,203,336. That's a large value. Good job. We're done with our lattice algorithm now. Number 5, round the leftmost digit and find the exact computation. So we're going to use our friend PEMDAS over here. I've got our little graph up here. PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. 883 plus 467. We're going to get 1348. Then we will divide, and we get the decimal. We get 10.05970149. Our largest leftmost digit is going to be 1. 5 times 254 plus 523. So we're going to multiply first. 5 times 254 is 1,270. Then we'll add. So we plus, that by 523, you get 1,793. 35 plus 7, you get 42. It's very important we stay in the order of our friend PEMDAS, and our answer will be 42.6904761. Our furthest left digit will be 4. We don't need to round up because that 2 is below a 5. Remember, 5 or higher, we round up. 4 or below, we stay where we're at. Let's look at C. 620 times 430 divided by 293. Let's see. Multiplication becomes before division on there, so we need to multiply first. 620 times 430 will be 266,600. Then we shall divide by 293. We get 909.8976109. And what is our largest left digit? That's right. It is 9. Good job. Homework number 6. This will be problem A. Demonstrate how you perform arithmetic in bases other than 10. In base 5, the digit symbols are 0, 1, 2, 3, and 4. Therefore, if the result in any column exceeds 4, convert this base 10 number to base 5 before proceeding. Okay, so we need to look at this first value here when we're adding. 2 plus 3. Okay, so we have 2, 5. Have that there, plus 3, 5 equals 5, 10. 5 is not a symbol of 5 because remember our symbols are 0, 1, 2, 3, and 4. Therefore, we need to do some converting. So we have set this up here. 1 times 3 plus 2 times 1 equals 5. And that's going to equal 12, 5. So we put our 2 here, carry the 1 up. Then we're going to have 1, 5, that's here. 3, 5, that's there. And then another 3, 5, that's going to equal 7, 10. 7 is not a symbol of base 5, so we need this to equal 7. Get our numbers. 1 times 3 is 3. 4 times 1 is 4. 3 plus 4 is 7. And we have these two numbers here, 1 and 4, and we get our 14, 5. So 14, there's that. We're supposed to have a 1 up there. Whoopsies. Yeah, we need to move that 1 over there. So let me annotate for you. I'm sorry, messed up on my PowerPoint here. That one's in the wrong place. We need a 1 right here. So this one is the red one up there. Sorry, 1, 5 plus 4, 5. That's the 4 there. Then our other 1, 5 here. All right, I'm going to go ahead and erase that now that y'all seen that. Okay. Equals 6, 10. 1 plus 4 plus 1 equals 6. 5, 5, 5. That'll end up being in the 10. 6 is not a symbol of 5. We know that our 4 symbols are 0, 1, 2, 3, and 4. So we need to find out an equation to break it down with using those symbols. 1 times 3 is 3. 1 times 3 is 3. 3 plus 3 equals 6, which was what we had. And we're going to get 11, 5. So then we have our 11 here. So our final answer will be 1,142 with a base of 5. Okay, let's get to our next problem here. Oh, homework number 6B. Demonstrate how you perform arithmetic in bases other than 10. In base 6, the digit symbols are 0, 1, 2, 3, 4, and 5. Therefore, if the result in any column exceeds 5, convert this base 10 number to base 6 before proceeding. Okay, let's get started here. Okay. So we have 628, 6 plus 73, 6. What we need to do first, we have 8, 6 plus 3, 6. 8 plus 3 equals 11. 11, 12 will be it. We know that that is not a symbol of our digits. So 1, 2, 3, 4, and 5. So we're going to use our digits to equal that. 1 times 5 is 5. 2 times 3 is 6. 5 plus 6 is 11. We're going to get 11, 6. Oh. Let's see. Oh. So we have 1 here. And then our, well, it kind of messed up again. So we'll have that 1 there. Try to draw on it again, but y'all kind of get the click there. Okay, and so our next one will be 1, 6. We have the 1 here. Plus 2, 6. Plus 7. That equals 10. 10, 12. So then we have 1 times 5 plus 1 times 5. That's going to be 5 plus 5. Ooh, that one says 11, 6. That's going to be wrong. Anyways, that should be 1 times 5 and 2 times 3. Okay, and then we get our 11. This one is supposed to be on top of the 6. My formatting's messed up on my PowerPoint. Then we get 1, 6 plus 6, 6. There's the 6. That's going to equal 7, 12. 1 times 3 is 3. 1 times 4 is 4. We get 7, 6. All right, that's it. Homework number 6C. This one will be subtraction rather than division, so we will have to use our borrowing skills on this one. So 4 minus 3, we will get 1, 5. Okay, 1 is less than 3. Okay, right here, we see that we need to subtract 1 from 4. Well, 1 is less than 4, so we need to borrow. So we're going to borrow from the 4, and this 1 will turn into 11. That makes that 4 a 3. So now we have 11. Remember, our base is 5, so this gives a sum of 5 plus 1. So 5 plus 1 would equal 6. And we need to subtract it from 4. That gives us 2. So basically, we're borrowing a 5 here. So 5 plus 1, because we added the 1 here, base 5 could be 11. But what we're doing is 5 plus 1 is 6. We have our 6 here. We're going to subtract 4. That's 2. And then we're just going to bring down our 3, and we get 321 base 5. Homework number 6D. Okay, so we're going to do, the problem is 5035 minus 245. All right, let's take a good look at this one. Okay, first thing we want to do, we see this 3 here. You see that 4. We cannot subtract that 3 from the 4 because it is less than. So we need to borrow. We can't borrow from the 0 here because it has no value. We need to borrow from the 5. So we're going to borrow 1 from the 4 here. Scratch it. So that's 4. We get 13. Okay, and since we had the value of 5 and we're adding 3 for 13, 5 plus 3 will be 8. 8 minus 4 is 4. So we have our red 4 there. Kind of shows it here. So 5 plus 3, those were the 3 we added because that went from 3 to 13. So 3. That's how we get the 4. Now we need to do our next value over. 0 is less than 2. We can't do that. We got to borrow. This won't be a 4 that we borrow this time. We scratch it, and it's going to be a 3. So that's going to make that 0 a 10. And since we must borrow from the 4, that turns a 4 into 3. Then 0 turns into 10. Now, we didn't add any value in the singles place. So that 5 is still going to remain 5. So 5 plus 0 is 5. And we subtract our 2. We get our 3 here. And then we just bring our other 3 down. So we have 334. And then 5 should come after that. All right. I hope you understood these 6 math problems. If you want, you could take a look back and practice some of them. And I hope my steps along the way will help you out. Let's see. You can take a look back through some of these. I'm going to scan through, and you can see I have some speaker notes down here that you could pause. Just little help with the equation, 5 sentences or so. And that will really help y'all out on a couple of these. Give you some tips and all that good stuff. But other than that, thank y'all so much for tuning in. Have a good week.